Okay, good morning. Seems like most of you have issues working on the nonlinear pharmacokinetics problems. So I'm going to do a recording of the sample problem that was provided at the end of the lecture handout. So the specific problem that I'm talking about now was provided in slide number 37. So slide number 37. So today is March 26, 20. So in that problem, you see that there are two doses and two steady state levels. So dose, milligrams per day, and steady state levels in milligrams per liter. So the first dose was 300 milligrams, and the steady state was 9 milligrams per liter. At a higher dose, 400 milligrams, the steady state level was 16 milligrams per liter. So the question is, what dose will provide 20 milligrams per liter? So we have to first calculate Vm and Km before we can do this problem. So the first step, as is shown in slide number 38, is to look at the model in terms of the graph that is given there. So you have daily dose divided by steady state in the x-axis, and the daily dose in the y-axis. So based on that, we can have a daily dose, milligrams per day, and then daily dose divided by steady state. So $300 milligrams there, the daily dose divided by steady state is going to be 300 milligrams divided by 9. So that is 33.33. If you look at the units, if you do dimensional analysis, you'll see the numerator is milligrams per day, and the denominator is milligrams per liter. And so the unit here will be liters per day. Okay. Then the daily dose when the daily dose was 400 milligrams. 400 divided by 16, 25 liters per day. Okay, so this is what we are using to calculate the VM. There are a couple of different ways of doing this. One thing would be, as I mentioned, we can just simply take the slope, because there are only two data points, and this is what is mentioned in slide number 39. You know, it's clearly written there. The slope, you know, is going to be equal to Km is equal to initial dose, which is 300 milligrams per day, minus 400 milligrams per day, divided by 33.3 liters per day, minus 25 liters per day. And so that'll work out to, you know, negative 12 milligrams per liter. Okay, so since, you know, you report positive value, this is a negative slope, because as you can see, you know, the line would be something like this. If I were to go back and draw it in this graph, you know, you'll have a negative slope. Okay, so that's why you have a negative Km. And so the actual numeric value for Km is 12 milligrams per liter. Okay, now this is pretty much similar situation to y is equal to mx, negative mx plus c, you know, where m is the slope, c is the intercept, right? And then here y, if you go back and look at the graph, is the daily dose, and x is, let me write this properly, daily dose divided by steady state, right? So the intercept, on the other hand, is defined in this model as Vm, right? So we can use this to actually calculate your Vm. So using that, you can pick any one of those. Because this is a straight line, we only have two data points. You know, we can just pick any one of those lines. So let's say we are picking the dose of 400 milligrams. So if we plug in 400 milligrams on the left side of the equation, and then negative 12 milligrams per liter times the x should be 400 divided by 16, which is 25 liters per day, plus C, right, which is your VM. Instead of C, I'm going to write VM. So your VM is going to be equal to 400 this is 400 milligrams per day, 400 milligrams per day plus 12 times, so we are solving for VM, 12 times 25 is 300, 400 plus 300. So if you do the dimensional analysis, milligrams per liter times liters per day, that's going to be milligrams per day. And so 400 plus 300 is 700 milligrams per day. So now you have your VM and KM, right? VM is 700 milligrams per day and KM is 12 milligrams per day. Now we can go back and look at the Michaelis-Menten equation, which says, dose is equal to VM times C, which is our, steady state, Km plus C. And so all we need is VM is 700 milligrams per day times the steady state that we desire, that is required, is 20 milligrams per liter. And the Km is 12 milligrams per liter. And again, the required steady state is 20 milligrams per liter. So you do the math and you'll get the final answer as 437 milligrams per day. So that is the dose that is required in order to get a steady state of 20 milligrams per liter. So hopefully that explains the math. As I mentioned, it's pretty straightforward. Try to review this video before attempting the practice problem and then take the quiz. And if you still have any questions, let me know.